Our today's lesson is about exponential growth. So if the number of population in a city is A, and this number increases by a percentage rate R, so what is the number of the people in the city after 1 year? Let's take an easy example before deducing the rule. If the number of the population in a city is 50,000 and the percentage rate of increasing is 10%. So how can we find the number of people after 1 year? So you will find the 10% of 50,000. So 10% of 50,000, it's 10 over 100 times 50,000. It will be 5,000. Then after 1 year, the population will be 50,000 plus 5,000. So it's going to be 55,000. So if you are talking about a variable A, so this is the number of the population A. After 1 year, you will find the rate, this is R, is the 10%. So it's the rate multiplied by the total number. It's 50,000. So you will multiply R by A. So the number of people after 1 year, it's A. This is the original value or the original number plus the increase in number. It's R, the rate multiplied by A. So it will be, we can take A as a factor. So A multiplied by 1 plus R. What about the second year, after 1 year? After 1 year, it's A multiplied by 1 plus R. What about the second year? The second year, the population is going to be A multiplied by 1 plus R, okay? Plus this R, the rate of increasing, multiplied by what? Multiplied by A and 1 plus R. So what is R? R is the rate of increasing multiplied by, what is A multiplied by A plus R? This is the number of the population. I'm talking about the second year. So here we have a common factor. What is the common factor? It's A plus R is repeated and we have A is repeated. So we can take A, okay, and 1 plus R as a factor. If we took A as a factor and 1 plus R as a factor, then you are left with 1 here, because this expression has been written. So 1 plus R. So we have A, and we have A plus R multiplied by A plus R, so we can write it as 1 plus R to the power of 2. So again, the number of people in the first year, after 1 year, it's A multiplied by 1 plus R. The number of the population after 2 years, it's A multiplied by 1 plus R squared. It's A multiplied by 1 plus R squared here, as you see. So what about the number of people after 3 years? After 3 years, again, I said that the number of people in the city is A. So after 1 year, it's A plus A times R. This is after 1 year. So after 1 year, we can take A as a factor. Then you have A multiplied by 1 plus R. And after 2 years, it's A multiplied by 1 plus R to the power of 2. What is A? A is the original number. And what is R? The rate of increasing. And what is 2? The number of years. So after 3 years, you will get the last number after 2 years, it's A multiplied by 1 plus r to the power of 2. Then we have an increase in the number, which is r multiplied by the number of people. What is the number of people? It's A multiplied by 1 plus r to the power of 2. Then we can take r to the power of 2 as a factor here. We can take r to the power of 2 as a factor here. And we have also A is repeated. So we can write A multiplied by 1 plus r squared. And then you are left with, here we wrote this expression. This expression has been written. So we have 1 here plus r. We are left with r. So after 3 years, it's A multiplied by 1 plus r to the power of 2 multiplied by 1 plus r. So it's 1 plus r to the power of 3. So we reach to a conclusion. What is the number of people or the number of the population? Number of population. After n years is going to be A, the original number, multiplied by 1 plus r to the power of n. Let's analyze it. What is n? N is the number of years. Number of years. What is r? R is the rate. Written in the decimal form. Written in the decimal form. Like if it was 10%. So 10% in the decimal form, it's 10 over 100, which is 0.1. If it was 15%, so 15% in the decimal form, it's 0.15. So what is R? Is the rate of increasing written in the decimal form. What is A? A is the original number. A is the original number. That's it. Let's have a look at this example here. Yusuf bought a house by 1,350,000. Here's 1 million. This is the price of the house. 1,350 pounds. And its price increases at the rate 2.5% per year. So this is the rate. We write an exponential function which represented the price of the house after n years. So what is the exponential function, if you remember? It's A multiplied by 1 plus r to the power of n. A is the original value, the price of the house. So what is A? A is 1,350,000. This is A. What is the rate R? R is 2.5%. 2.5%, it's a 2.5 over 100, which is 0.025. This is R. So what is R? 0.025. So we write an exponential function which represented the price of the house after n years. So it will be 1,350,000 multiplied by 1 plus, what is R? R is 0.025 raised to the power of n. Okay, what is n? Is the number of years. We can write, instead of n, we can write t. Okay, n or t. So raised to the power of t. We can write here raised to the power of t. So it's to the power of t. As the formula written in your book, t is the number of years. So this is the exponential function which represented the price of the house after 10 years, after n years. So it will be 1,350,000. And 1 plus 0.025, it will be 1.0, okay, 25 to the power of t. If you want to find the price of the house after 6 years, so instead of this t, you will write 6. This is the time. So it will be f of 6 here. It will be 1,350,000 times 1.025 raised to the power of 6, approximated to 1 million. Okay, 1 by using the calculator, 1565586. So we have here 1,565,586. That's it. The number of cows in a cattle farm is 80 cows, and the reproduction rate of these cows is 18% annually. Find the number of cows after 4 years. So here, what is A? A is the original number is 80 cows. And what is R? R is the rate percentage. It's 18%. We can write it as a decimal as 18 over 100, which is 0.18. What is T, the number of years? T is 4 years. Okay. So I want to find the number of cows after 4 years. So write the exponential function, which is A multiplied by 1 plus R to the power of T. What is A? A is 80 cows multiplied by 1 plus R. What is R? Is 0.18 raised to the power of 4. So it's going to be 80 times 1.18 to the power of 4. By using the calculator, it will be 155 cows. The number of spectators of a football team decreases at the rate of 4% each match. If the number of spectators in the first match was 36,400, this is A, 36,400, okay? Estimate the number of fans in the 10th match. So we have here A is 36,400. And we have R is 4%. 4% is 4 over 100, which is 0.04. This is R. And I want to estimate the number of fans in the 10th match. So T equals 10. What is the exponential function? It will be A multiplied by 1 plus R to the power of T. What is A? 36,400. Multiplied by 1 plus R. What is the rate? It's not plus. In this case, it's not plus. Why? Pay attention. It's not plus because decreases. So it will be minus. So it will be minus 1 minus 0.04 raised to the power of T. Raised to the power of T. And T is 10. So it will be 36,400. And then by using the calculator, 1 minus 0.04, it's 0.96 because it's 400s. Raised to the power of 10. By using the calculator, you will find the number of spectators. They will be 24,200. That's it. What about the compound interest? We follow this rule in the compound interest. B, what is B? Is the principal or the original value. B is the principal or the original value or the sum of money deposited in the bank. And T is the number of years. And N is the number of times per year. Okay, so it's P, the principal, multiplied by 1 plus R. What is R? R is the rate. Or is the rate written in the decimal form. Divided by N. What is N? Is the number of times yearly. The number of times yearly. raised, all of them raised to the power of nt. T is the number of years multiplied by n is the number of times yearly. Let's take an example. Muhammad deposited a capital of 15,000 in a bank. So what is B? The principal is 15,000. We write here B. With annual compound interest 7%. 7% is the rate. Here R is 7%, which is 7 over 100. It's 0.07. Find the sum of the capital after 10 years. So we have here T, the number of years is 10 here. In each of the following cases, if the interest compounded annually. So if the interest compounded annually, that means it's one time, once per year. So the interest is annually. So its number of times per year is one time, once per year. Let's have a look at the rule again. P multiplied by 1 plus r over n, all raised to the power of n times t. So A equals P multiplied by 1 plus r over n, all raised to the power of nt. Okay? So in the first one here, number 1 here, it's one time yearly, so n equals 1. N equals 1. So write 15,000 multiplied by 1 plus r. What is r? R is 0.07 divided by 1. Why 1? Because it's once per year, annually. So all raised to the power of n times t. So what is n? It's 1 multiplied by 10. By using the calculator, it will be 1. It will be 2,950.27. This is the sum of money he will get after 10 years if the interest compounded annually. I want to find interest compounded quarter annually. The meaning of quarter annually, it's 4 times per year. So n equals 4. Why is that? Because it's a quarter annually. So write P, it's 15,000 multiplied by 1 plus R. What is R? Is the rate written in the decimal form. It's 0.07. All divided by 0.07 divided by 4. All raised to the power of n2, n multiplied by t. So it's 4 multiplied by 10. By using the calculator, it will be 3,023.96 pounds. So this is the amount of money he will get after 10 years if the interest compounded quarter annually. If the interest compounded monthly, monthly means 12 times per year. So n is 12. So write the rule, A is P multiplied by 1 plus R divided by n, all raised to the power of n2. N multiplied by t, so it's 15,000, okay? 1 plus the rate, it's 0.07 divided by 12. Why 12 in this case? Because the interest compounded monthly, all raised to the power of 12 multiplied by 10, okay? By using the calculator, will be 3,014.92. It's 30,144.92. I hope you enjoyed this session. See you in the coming episodes. Goodbye.